So now we're going to look at control charts, and we're going to focus on the differences between special cause and common cause. We're going to look at control charts, not in this sense for control, because control from a statistical point of view comes after you've got your process fixed, you know exactly how it's working. But control charts are really powerful for what we call diagnosis. And we're going to look at using control charts, so look back in time to try and figure out what has gone on and to help you utilize your causal framework to identify which causes might be occurring and when they might be occurring. So we move from talking about descriptive statistics to predictive statistics, and we do that by using one main statistical rule, which is that in a normal distribution, a normal natural variation, we can say that different aspects, different quantities of the measurements or the outcomes will fall at certain points within the standard deviation away from the mean. So at one standard deviation away from the mean, 70% of all our points will lie, so they're kind of close to the mean, because that's how it works from a statistical point of view. If we go out a bit further, so if you take 2 standard deviations away from the mean, either side, that's 95% of all your variation. And then finally, if you go to 3 standard deviations outside, then almost all of your variation should occur within those limits. Okay, so that then allows you to say that outside of those limits is very, very rare. So we expect them to be within those ranges. This means then we can go back and turn it on its head and say we can use that rule to decide whether something is varying normally or abnormally. So you can then put what we call control limits on your chart, and you can go back and look at your chart and say, okay, I can now work out where things are not normal, because where things are not normal gives you a clue as to potential different types of events that change your outcomes, your process outcomes. So this is where we get into the nitty-gritty of the difference between special causes and common causes. So common causes are the things that make you your process behave the way it does. So to take an example, we use in the workshop about the time driving to work. So you might say it takes between 15 minutes and half an hour to driving to work, because depending on things that occur all the time, so the amount of cars on the road, the weather, what time of day you go, etc., they would kind of cause you that natural variation. Okay, if it takes 45 minutes, or it takes 5 minutes. If it takes 5 minutes, you might have flown there. If it takes 45 minutes, that could be because there's been an accident in the road, or it could be you had a problem with your car, couldn't get the start. Those things are what we call special causes, and using a control chart helps you distinguish between those incidents we talked about in the causal framework, or things that are just the way they are, and they have different investigative routes and different reactions to how you deal with them as you go forward. So common cause variation is produced by the process itself. It's one of the main reasons why the process behaves as it does. Special cause is unpredictable, and they're quite big shifts, and they're actually easy to find out what's gone on. So special causes are good in some sense because it gives you an indication of like when things are having a massive impact on your process. However, what really drives your performance is the common cause variation. So you have to remove the special cause, understand why that has occurred, and don't get sidetracked by that, and focus on understanding what the common causes are. Because what you do about it makes a difference in terms of fixing things that are one-offs is important, but it doesn't really help you get to grips with why the process behaves as it does. Similarly, if you want a stable process, then you need to remove the special causes, not the common causes. So we use control charting, looking as a diagnostic tool to go back in time, and we have 4 rules to do that. There are quite a few more rules, but they're much more sensitive, and most processes 4 is enough. So we can draw on our control chart, we can draw the mean line, we can draw the control limits, which are 3 standard deviations above and below the mean. And we can also put warning limits, which are at 2 standard deviations, so they're like a tighter band and tells you when things are starting to move potentially. So we use visual rules. So the first visual rule is obvious, that if you've got a point outside the control limits, then something has gone awry. There's a definite special cause occurring there. So you can go and track out, well, what happened on that particular order, or that particular product, or that particular day or shift, or whatever it is. The second rule is if you've got 2 out of 3 points outside the warning limits, because statistically that's unlikely to happen if things are normal. So it tells you that something is not normal and something is either occurring or about to get worse, whatever that might be. Rule 3 is about trends. So a true trend is only when you've got 6 points in a row going up or going down. So don't get sidetracked by a couple of quarters or a couple of weeks or a couple of months. You've got to have 6 points to say, well, something significant has changed, and that process is now not normal. It's possibly got a new mean, might have got a new variation pattern. And the final rule is where you've got 8 consecutive points either side of the mean line, which suggests a shift in performance, either good or bad. So you can use those rules to interrogate your historic data and try and find out what was going on at different points, whether you've got special cause, whether you've got common cause. And if you remove the special causes from consideration, find out what happened there, and then you can focus on finding out what causes the common variation. One thing to remember is that we talked in the workshop about moving average. So if you calculate your control limits on just the data, those limits will be quite wide, because they assume, right, that everything is normal. Because if the number's in there, the simple calculation says, oh, it must be part of the distribution, it must be normal. But in actual fact, we need a more sophisticated way of doing that, because you might have abnormality in your data set which you need to be aware of. So we use a moving average as a statistical trick, almost technique, to give ourselves a better chance at identifying what the normal standard deviation is. So because we then calculate a standard deviation on the moving average rather than the data itself, and we use that for your control limits. So that, if you look at the 2 examples there, it's the same data but different control limits, and it gives you a more sensitive window to look at your data, because it's kind of highlighting that where things are on the edge of the distribution, which you wouldn't do normally. Don't have to worry too much about why, it's just a good idea to use that. And the final bit is that once you've made a change and you've made an improvement, then you should be able to see it in the control chart. Things will be different, abnormal, and only when you've got evidence of that, and statistical evidence, then you can change your control limits and change your mean and develop a new chart. And that's when we move into that control phase rather than the diagnostic phase, because normally things look better at that point in time.